Here. Myself, Chirag Bangera, along with my colleague Joel Thomas, is going to put forth the presentation about antimicrobial packaging system for food packaging. So let's begin. As it is known, the growth of bacteria in the foodstuffs may create an undesirable effect, which may lead to the decrease in the shelf life and even may cause decrease in safety of it, which may treat the security of public health. Now, many such latest technologies have been developed, which has been adopted by us, and we use it. We use the resources. We make the use of resource, and also search for the alternative options. But still, this has not been accepted or satisfied to the consumer needs. Mainly the products which are extracted from the natural resources, from grape fruits to the bacterially synthesized antimicrobial peptides. It is also known as mustard oil or bacteriocins. These have been the alternative options for the food processes or the and agents we can use. Let's start with the introduction part. Let's see what is antimicrobial packaging. Antimicrobial packaging is one of the applications of active packaging. We can say one of the form of active packaging. It prevents the surface growth of pathogenic microorganisms in food by use of antimicrobial agents, where there are more chances of where there are large portion of spoilage and contamination may occur. It allows a controlled release of antimicrobial agents in the food surface during the distribution and storage part. Now let's see what exactly is active packaging. Active packaging actively changes the current situation or the current condition of the packaged food by increasing its shelf life, and eventually if the shelf life has been increased, the safety of the food has also been increased, and the product can be a very good, it can last long. It also increases safety and sensory properties, along with which its quality has been maintained. These in active packaging may involve a few necessary steps like antimicrobial products, which reduces the growth of microorganisms, addition of carbon dioxide, which suppress the growth of microbes present already inside the product. Package. Ethene absorbers, which prevents the ripening of fruits, and then there is oxygen scavengers, which removes the oxygen to stop oxidation, or it may stop the mold growth. This is an illustration by which we can it explains what active packaging is. The active package or the packaging system has a barrier layer outside, which prevents many dangerous or harmful hazardous chemicals to come inside, or even if there are already present inside, we can extract it or we can stop the growth of it. This is it. The advantage of this active packaging is that layer or the layer is in all the four sides of the package, and it helps us exchanging of it helps this non-exchanging of the gases. We have to create a vacuum inside the package so that there is no exchange of gases. This is a conventional packaging system where the moisture barrier or the oxygen barrier, if both of them are together, been present in a package, but still there is a moving of gaseous layer from one side to another side. But because of antimicrobial packaging or active packaging, you can say, we have been achieved a very good barrier layer through which we have increased the shelf life of the product, along with the safety of the food has been increased gradually. Now let us see more about active packaging. That is, among many active packaging applications such as moisture control packaging, oxygen and carbon dioxide scavengers, polymer films with selective permeability, gas permeability, and microwave susceptors. Antimicrobial packaging is one of the most promising innovations in the near future of active packaging technology. The second phase, we can see antimicrobial packaging or the system is classified into two phases. That is active packaging and control released packaging. First phase have been done. The second phase or the last phase will be explained by my colleague Joel Thomas. Thank you.
Hello. So controlled release packaging, it is a sophisticated form of active packaging. Actually what controlled packaging does is that it forms an environment inside the pack which is covered from all the sides, that is top, bottom and all the sides, with a special layer which has chemicals like chemicals which have antimicrobial in nature applied on it. And it works only when the product is filled inside the pack and the product is filled inside the pack and vacuum is applied, so it slowly transfers the antimicrobial agents inside the package. So these are the two types of mechanisms of which antimicrobial agent uses, like packaging food system, in which there is no headspace like in the package headspace food system. Only this is the package, the thickness of the package, like Tetra Pak or any other form of packaging, the thin thickness is there, that is that package side, and this is the food which is filled in the content area of the pack. So when the food is filled, or it may be a solid or a liquid food, when it is filled inside, because of the moisture of the moisture present or in that, it diffuses the chemical which is present on the package into the food. So this causes the it stops the growth of microbes, and this is package headspace food system. In this, the headspace is there, when the product is filled and the pack is sealed, because of equilibrium, it causes the diffusion and the chemicals are released into the headspace and it is protected. Antimicrobial agents has these are the components of antimicrobial agents: natural antimicrobial agents and chemical antimicrobial agents. Two types of antimicrobial agents are there. They are obtained from plants, animals, and microorganisms. And chemical antimicrobial agents use sorbic acid and benzoic acid. And these films, LDPE, LLDPE, PET, polyolefin, and EVA, are the base materials on which these antimicrobial agents are applied, so that they are applied to the package. This is actually an antimicrobial agent base layer. On this, the antimicrobial agent is applied. This is actually a 300 micron thick layer of cellulose acetate, which is made in such a way that the amount of monomers induced inside the layer is more than normal cellulose acetate films, because this causes the porosity of the layers to reduce. The porosity of the layers are reduced because the amount of monomers induced inside the layer is more. So when the porosity is reduced, it controls the amount of antimicrobial agent diffused into the pack. So this is how it is controlled. The word control comes in here, because when the porosity is reduced, the amount of antimicrobial agent induced is reduced. So this helps in increasing the time in which the antimicrobial agent is induced into the pack. So we will get a shelf life of more than 6 months, or more than for food products like such as meat, fish, and others. This is actually a table in which edible polymer is the edible film, which is the base layer, and for specific mode, different antimicrobials are there. So for organic acid and anhydrous solutions are used for molds for different layers. These are the applications used for packaging of meat quality products and fish, and used for packaging of fresh fruits and vegetables. It's also used for ready-to-cook foods, and it has a huge application in pharmaceutical